Hello everyone, welcome to Mtabisi Mhlongo's Mathematics and Physical Science YouTube channel. And today we're looking at a topic test on organic nomenclature, which is normally question 2 of the exam paper. And today we'll do this February 2025 topic test question. So let's start with the first question in here. Um, that was a multiple choice. Now I'm just going to answer this one in within the question. Okay. So, which one of the following is the correct regarding the name and structural formula of a functional group for aldehydes? Now, aldehydes, you see them with an H and C double bond O. So, C is the correct answer because that's that functional group is called the formal group. And then, which one of the following um, compounds are chain isomers of each other? 3-methylpentane and 3-ethylpentane. This cannot be because now you're having two different molecular formulas. Pentanoic acid and propyl ethanoate. Um, that can be, so we put a dash on it. Chain isomer. Now we're talking chain isomer. This cannot be it. Why? Because this is a carboxylic acid and this is an ester. So they are functional isomers, this one. So it's not correct. 1-fluoropropane and 2-fluoropropane. 1-fluoropropane and 2-fluoropropane. Now, that is position when you talk 1 and 2. That is also incorrect. Then you have methylpropane and butane. Now, methylpropane is just a CCC with the CH3 group here. And the rest is CH3 and CH and CH3. While butane is just CH3, CH2, mm, CH2, and CH3. Okay, now done with the first question. Let's have a look at the next question. I'm thinking it's question 2. Now, in question 2, we're given the letters A to E on the table below to represent 5 organic compounds. A up to E is given, and the first question is said to define homologous series. You have to define the term homologous series. Now, what is a homologous series? For a homologous series, you need to define it as that's 2.1. Right. Now, this is a series of organic compounds. A series of organic compounds that can be described by the same general formula, or in which one member differs by CH2 group. To the next. One member differs from the next by a CH2 group or with a CH2 group. Okay, back to 2.2.2. Write down the IUPAC name of compound A. Now, this is compound A. So I'm going to do it within this. Compound A, we see that that contains a alkyl group. So we're going to start naming from the right to left. So 1, 2, 3, 4, 5, 6, 7, and 8. Now, Our substituent will be this and this. So let's get to the naming part. We have the following. We have that this is a oct at carbon number 3 ion. And we also have ethyl as a substituent in carbon number 5. And we also have in carbon number 6 a methyl group. So let's jot this down correctly. I'm going to do a little bit of erasing here so that it doesn't confuse us in the next questions. Okay, so you've seen what we've listed there. I said we have oct, 3 wine or iron, and then 5 ethyl, and 6 methyl. Now, to give the name, this would be a 5 ethyl, 6 methyl, octyl. Well, oct 3 iron, oct 3 iron, oct 3 iron. And the next question wants us to check also the IUPAC name of compound B. Compound B. Now, in compound B, we're also going to do this. Numbering first, 1, 1, 2, 3, 4, 5, with a substituent here and here and here, of which is a 2 bromo, 3 chloro, and a 4 methyl, and the longest chain being a pentane. To erase that, so we can give it a name. Okay, 2.2.2, we have pentane as our longest chain. We have 4 methyl, we have 2 bromo, we also have 3 chloro. Now, to come up with a name for this, we need to follow the alphabetic order that says we have 2 bromo, 3 chloro, 4 methyl pentane. 2.3.1, write down the structural formula of compound D. Compound D. 2.3.1, they say they want 2,4,4 trimethyl pent 2 in. So we're looking for a 1, 2, 3, 4, 5 carbon, and there is a double bond in the second, and the rest we can put our single bonds. And at carbon number 2, there is a methyl group, and at carbon number 4, methyl group as well. Now the rest of the structure, you fill it up with H's, H, 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 H. Make sure you count the number of hydrogens. that you have drawn. See, I'm missing one here, so I would lose a mark for whole structure. Okay, now we look at 2.3.2, molecular formula of compound C, pentan 2O, pentan 2O, pentan 2O. 2.3.2, pentan 2O. Now that is 1, 2, 3, 4, 5. And at carbon number 2, we find the carbonyl, and we're looking for the molecular formula. So we'll have to do counting here. How many carbons are there? That is a C5H. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10, C5, H10, and O. There's only one oxygen. 2.3.4, if there is any. 2.3.4, structural formula of the functional group for compound E. Now, what is compound E? Compound E is an ester. So what is this functional structural formula of the functional group for an ester? 2.3.4. That is a C bonded to an O, bonded to a C, double bond O, and bonded to one other atom. Okay, we have 3 more left. That says compound E is being prepared. Now, compound E is what we just drew, which is the ester. It's prepared by 2 organic compounds in the presence of a catalyst. The IUPAC name of this compound E. Compound E, as we look from left to right, we see that the O comes from the alkyl. So when the O comes from the alkyl, we would definitely state that 2.4.1 alkyl substituent is a propyl, and the one that contains a carbonyl group is a ethane. Now the esters are having a suffix of OH. 2.4.2, if an ester has been made by 2 organic compounds and you see the alkyl substituent, the one next to O without the carbonyl, that definitely tells you that this is the alcohol part. So the alcohol there would be propanol, so that's why you have propyl, propanol, and then made with ethanoic acid. 2.4.3, I think that one is the one asking about what is the catalyst that is being used. Write the name or formula of the catalyst. Now it's either you write H2SO4 or sulfuric acid. Okay, now we try and get to our last question as quickly as possible. It's the first part of the last question. Also similar, letters A up to E with 5 organic compounds. Write down the letter of the compound that is an unsaturated compound. Now, this is a compound that has a double bond between the carbon-carbon chains. Already, I can see that A, C, D, and E do not have a a double bond within the carbon-carbon chain. So B is the only left over. So 3.1.1, well, 3.1 will be B. Then in 3.2, I think we are asked of definition of a functional group. Now, a functional group is a bond or an atom or a group of atoms that determines the physical and chemical properties. Physical and chemical properties of a group of organic compounds. Right, 3.3.1. Write down the name of the functional group of compound A. Compound A is a carboxylic acid. So we want the name of that functional group. Well, not the structure. So this is a carboxyl or carboxyl group. Carboxyl group. In 3.3.2, they wanted the name of the functional group for E. E is a hydroxyl, so you can see it's an alcohol. So it's hydroxyl or hydroxyl. Hydroxyl group. 3.4.1. What are we looking for? Write down the structural formula of the functional group for compound A. That is a carboxylic acid. So a carboxylic acid has this as a functional group. C double bond O, bonded to an O, and an H. 3.4.2. 3.4.2 for compound B. Compound B is C4H8. That is CnH2n. And CnH2n has the general formula for an alkene. So an alkene will be seen by this functional group. Okay, 3.5.1 maybe. 3.5.1, we're looking for the structural formula of compound B, I mean D, compound D. Okay, now it is said that compound D contains a carbonyl group, and then compound C, they are isomers of each other. So if compound C has the carbonyl group in the last end of the structure, then compound D must have it in between, meaning to say the compound D is a ketone. Now, which ketone would it be? C, 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 double bond O with H's, and that is our isomer. What isomer did they look for? They said it, they're just isomers containing that. Right. The type of isomer that I showed would be a functional isomer. And why is that? 3.5.2. Why would I choose functional isomer of all the isomers there? Well, if you look at this, other one is an aldehyde, and so compound C, not the other one. Compound C has the carbonyl group at the end of the carbon chain, making it to be an aldehyde. With a formal group. So now that changes the um, functional group when it comes to compound D. So in compound D, the carbonyl group is found in between two carbon atoms in the carbon chain. So the C double bond O group is in between two carbons in the chain, or in the carbon-carbon chain. The last two Okay, that's 3.6.1. Compound E, consider compound E. What type of an alcohol is compound E? Compound E, and well, you can see the hydroxyl is in the first carbon, so that's primary. 3.6.1, that's a primary alcohol. So the carbon containing a hydroxyl group is bonded to one other carbon. In the carbon chain. Then 3.6.2, structural formula for positional isomer. Now you want to change position. So if it's in the first, now you can put it in the second. So 3.6.2, 1, 2, 3, 4. And then we can put OH here, and then the rest is just H's. And that's it, we're done. Please like, share, and subscribe. Stay tuned for our next video. Thank you.